Chapter 7 Hydrogen. This theme focuses on enabling students to know about one gas, hydrogen, and that it is an important constituent of several compounds. It is found in acids and organic compounds. It acts as a fuel which makes its study useful. Learning outcomes. After studying this chapter, students will be able to describe the preparation of hydrogen from electrolysis of water, prepare hydrogen in the laboratory using zinc and acid, describe the properties and uses of hydrogen, correlate concepts of oxidation and reduction with addition and removal of oxygen or removal and addition of oxygen. Important terms and their definitions. Hydrocarbons. Compounds of carbon and hydrogen are called hydrocarbons. Hydrogenation, the process in which vegetable oils are converted into fats on treating with hydrogen. Oxidation, it is the reverse of reduction, that is addition of oxygen to a substance. Reduction, removal of oxygen from copper oxide to form copper. Introduction. Hydrogen is the highest of all elements. It is believed that the German-Swiss alchemist found that an inflammable gas was produced when a metal was dissolved in an acid. It was first prepared by Robert Boyle by the action of dilute sulfuric acid on iron nails. In 1766, the English chemist Henry Cavendish showed that hydrogen, which was then called inflammable air, was distinct from other combustible gases. Occurrence of hydrogen. Hydrogen is the most abundant element in the universe. The stars, including our sun, are mainly composed of hydrogen. Hydrogen is present in the atmosphere and in the Earth's crust also in very small amount. This important element is present almost everywhere. Acids, bases, and organic compounds like hydrocarbons, carbohydrates, proteins, fats all have hydrogen as one of their constituents. 3/4 of the Earth's surface is covered with water, a compound made of hydrogen and oxygen. Preparation of hydrogen from water. As we know, hydrogen is not available in its free state, so it has to be prepared from its compounds or in the laboratory according to the requirement. We can get hydrogen from these compounds by getting it displaced by a more reactive metal. These reactions are called displacement reactions. Let's take an example. Hydrogen prepared from water. Water contains almost 11.2% of hydrogen by volume. This hydrogen can be liberated when water reacts with metals or electric current is passed through water or electrolysis. Different methods of preparation of hydrogen. Displacement from water by metals. Metals such as sodium and calcium, when treated with cold water, liberate hydrogen from it. 2Na sodium plus H2O water is 2NaOH sodium hydroxide plus H2 hydrogen. Ca calcium plus 2H2O water is CaOH2 calcium hydroxide plus hydrogen H2. From water by electrolysis. On passing electric current through water, hydrogen is evolved. A few drops of dilute sulfuric acid or a few pellets of sodium hydroxide, caustic soda, are added to water to make it a better conductor of electricity. 2H2O water is 2H2 hydrogen plus O2 oxygen. Displacement from dilute acid by metals. Dilute sulfuric acid and dilute hydrochloric acid give off their hydrogen when they are treated with metals placed above hydrogen in the metal activity series. The reactions with potassium, sodium and calcium are highly exothermic and explosive, but the reactions with zinc, iron, aluminum are moderate and controllable. To know more, lead is not used to prepare hydrogen, although it is placed above hydrogen in the metal activity series, because the reaction is slow and the products PbCl2 and PbSO4 formed are insoluble and form a layer over the metal, preventing further reaction. Copper will not liberate hydrogen from dilute acids because it is placed below hydrogen in the metal activity series and cannot displace hydrogen from the acids. Reaction of metals with water. As all metals do not react with water, although some of them show vigorous reaction and form metal hydroxide or oxide and hydrogen gas. Metals like potassium and sodium react violently with cold water. 2K plus 2H2O is 2KOH plus H2. 2Na plus 2H2O is 2NaOH plus H2. Potassium reacts even with cold water so violently that hydrogen evolved could immediately catch fire. Calcium reacts with water but not so violently. Ca plus 3H2O is CaOH2 plus H2. Magnesium reacts with hot water forming magnesium oxide and hydrogen. Mg plus H2O is MgO plus H2. Metals like aluminium, zinc and iron react only with steam. 2Al plus 3H2O is Al2O3 plus 3H2. 3Fe plus 4H2O is Fe3O4 plus 4H2. Zn plus H2O is ZnO plus H2. To know more, metals like gold, silver and copper are submetals which do not react with water. Preparation of hydrogen in laboratory. Hydrogen is prepared in the laboratory by the action of dilute hydrochloric or sulfuric acid on granulated zinc. Zn zinc plus 2HCl hydrochloric acid is ZnCl2 zinc chloride plus H2 hydrogen. Let us perform an activity to know the procedure of preparing hydrogen gas in the laboratory. Reason of preference of zinc as the metal to be used. When pure zinc is used, the reaction is very slow because the layer of gas insulates the metal from the acid. Therefore, granulated zinc is preferred. It contains traces of copper as an impurity which catalyzes the reaction and prevents the decomposition of the gas on zinc. Properties of hydrogen. Physical properties. Hydrogen is a colorless, odorless, having no smell and tasteless gas. It is the lightest of all the gases. It is about 20 times lighter than air. Hydrogen is highly inflammable and burns with a pop sound. It has a pale blue flame. It is almost insoluble in water. Hydrogen is difficult to liquefy. Its boiling point is minus 253 degrees centigrade. Chemical properties. Hydrogen forms compounds with all the elements except noble gases. Water, ammonia and carbohydrates are some very important compounds of hydrogen. The combination of carbon and hydrogen forms innumerable compounds. These compounds are called reaction with nitrogen. Under ordinary conditions, hydrogen does not combine with nitrogen, but they combine together under high pressure in the presence of finely powder iron, which acts as a catalyst, and molybdenum, which acts as a promoter at 450 to 500 degrees centigrade to form ammonia. The reaction is reversible and exothermic. This is known as the Haber process or Bosch's process. N2 nitrogen plus 3H2 hydrogen is 2NH3 ammonia plus heat. Reaction with chlorine. Hydrogen combines with chlorine in the presence of diffuse sunlight to form hydrogen chloride gas. H2 hydrogen plus Cl chlorine is 2HCl hydrogen chloride. Reaction with oxygen or air. Hydrogen burns with a pale blue flame in air oxygen, forming water. The reaction is exothermic to the extent of explosion. This reaction gives out so much energy that is used to derive space rockets. 2H2 hydrogen plus O2 oxygen is 2H2O water. Reaction with sulfur. When hydrogen is passed through molten sulfur, it forms hydrogen sulfide gas. H2 hydrogen plus S sulfur is H2S hydrogen sulfide. Reducing property of hydrogen. The process of removing oxygen from a compound is called reduction. Hydrogen can remove oxygen from a number of metal oxides. That is why hydrogen is called a reducing agent. Oxidation and reduction. Oxidation. Addition of oxygen to hydrogen to form water is oxidation. Oxidation is the reverse of reduction, that is addition of oxygen to a substance. In an oxidation reduction, both reduction and oxidation occur. Reduction. Removal of oxygen from copper oxide to form copper is reduction. Examples: zinc oxide gets reduced by hydrogen to form zinc. ZnO, zinc oxide plus H2 hydrogen is Zn zinc plus H2O water. Black copper oxide turns to reddish brown copper on reduction with hydrogen. CuO copper oxide plus H2 hydrogen is Cu copper plus H2O water. Lead monoxide is reduced to lead by hydrogen, PbO, lead monoxide plus H2 hydrogen is Pb lead plus H2O water. Uses of hydrogen. For manufacturing ammonia. Hydrogen is used in the manufacturing of ammonia NH3 by Haber process. Ammonia is widely used to make fertilizers. For the hydrogenation of oils. Hydrogen is used in the manufacture of margarine and cooking fats. The process is called hydrogenation. In this process, vegetable oils are converted into fats by treating them with hydrogen. For the manufacturing of hydrochloric acid and methanol, used as a fuel. When hydrogen is burnt, heat is produced along with water, 2H2 plus O2 on burning, 2H2O plus heat. Liquid hydrogen is used as a fuel in rockets and guided missiles. For the production of the oxyhydrogen flame. Hydrogen is used in the production of high temperature flame, oxyhydrogen flame for cutting and welding of metals, for filling balloons. As hydrogen is lighter than air, a balloon filled with hydrogen rises in the air and drifts in the wind. If a weather instrument is placed in it, the balloon can be used for studying weather conditions. Test for hydrogen. Hydrogen burns with a characteristic sound or pop. This property is used as a test for hydrogen. Fast track chapter at a glance. Hydrogen is the lightest and the most abundant element. It is also present in the atmosphere and in the Earth's crust in very small amounts. In combined form, hydrogen is present in acids, bases and organic compounds as one of their constituents. Hydrogen can be liberated from its compounds by displacement reaction. It is displaced from water or dilute acids by treating them with a more reactive metal. In the laboratory, hydrogen is prepared by the reaction of zinc with dilute hydrochloric acid. Hydrogen is a highly inflammable gas. It burns with a pale blue flame in air-forming water. Hydrogen reduces a number of metal oxides to their respective metals. Hydrogen is used for manufacturing ammonia, for the hydrogenation of oils, as fuel, as a reducing agent, for producing an oxyhydrogen flame, for filling balloons. Chapter 8